Vehicle miles traveled is very interesting. As I mentioned to you, we're not going to be able to achieve some of the targets that people are talking about just simply through vehicle and fuel technologies. So what does that leave us? Well, the third leg of the stool is vehicle miles traveled. Now this particular figure is somewhat complex, but let me explain this to you, and I'm going to go away from the microphone, so I hope you can still hear me. This basically is 2005. This is the emissions in 2005. If this is the target value, which is we're shooting for we want a 70% reduction over the 2005 limit by 2050. This is what we have to achieve in terms of emissions. Well, how could we possibly do that? Well, one of the strategies is to have an average corporate mile per gallon gas equivalent of 50 miles per hour, or excuse me, 50 miles per gallon, okay, and a 1.5% annual increase in vehicle miles traveled. Okay? The population of the United States is going to grow. That usually means you're going to see more travel occurring in the United States. This says, well, let's assume 1.5%, which by the way is below the historic average, annual average, and let's assume that we will have an average corporate fuel economy of 50 miles per gallon. What does that get us? Well, it gets us to here. You don't have to be a Georgia Tech graduate, no offense to KU. You don't have to be a Georgia Tech graduate to figure out that that's not there. Okay? Well, what else do we do? Well, let's assume a 50 mile per gallon corporate fuel economy standard, but let's assume a 1% growth in vehicle miles traveled per year. Economic chaos. A 1% growth means the economy is not, well, of course we're probably in that now, but a 1% growth per year between now and 2050 in essence suggests we have serious, serious problems. Okay? Not necessarily a good idea. Plus, you'll see it doesn't get us anywhere near the brown line. Over here, a 100 mile per gallon corporate average fuel economy. 100 miles per gallon. Great idea. Maybe by 2050, I don't know. But also a 1.5% vehicle miles growth, you still don't get to the brown line. Finally, the scenario, the transportation scenario that gets you to that target of 70% below the 2005 levels is a 100 mile per gallon corporate, across all vehicles, average, 100 miles per gallon and a 1% per year growth. Ain't going to happen. Okay? So this is the idea of how challenging it is to meet these targets that sometimes scientists who are not engineers, no offense to scientists out there, and certainly politicians who are not engineers, throw these things around. Well, is it 80%? Is it 70%? Is it 2050? Oh, let's say 75% reduction, without having a clue about what that means in terms of the transportation system and what that requires of the transportation system. And if you're really serious about this, yes, you can in fact reduce vehicle miles traveled, and study after study after study shows you do it through pricing. You charge people. You raise the gas. Oh no. No one's going to vote for that. Let's put tolls on. Well, not so sure about that. Anything to make it more expensive, political leaders often shy away from very quickly. But you can ask any economist, and they'll say if you really want to reduce the demand, raise the price. And study after study shows. And there are different strategies that have been looked at. PAYD is pay as you drive insurance, which means the more you drive, the more you pay, which in fact should then discourage you from driving more. Mileage fees, as you get charged for how many miles you travel rather than by gas tax. All sorts of ways of dealing with it. But if you're serious about vehicle miles traveled, you need to look at the pricing strategy. The fourth leg, vehicle system operations, also matter. Depending on who you talk to and how you're applying these types of things, most people think you can get kind of 10 to 20% light-duty vehicle greenhouse gas emission reduction by making the system more efficient. Things like managing speed, trying to reduce XL, decel activity on the transportation system by vehicles, which causes disgusting things to come out the pipeline, out the pipe. Having the best tire inflation with regard to the rolling resistance, etc. So there are things that one can do also on the vehicle system operation side that could be helpful, which of course is what we as transportation engineers do. What about land use? What could we possibly do with land use? Well, there was a very famous study last year called Growing Cooler by the Urban Land Institute that said we can get a 30% cut in vehicle miles traveled with compact development. This sent shockwaves through the professional circles in the United States. 30% reduction in vehicle miles traveled. Well, what does that mean? Okay, well, what that means in essence is that 2/3 of all the development between now and 2050 is new or rehab. And then, of course, today's economy hopefully will not be the economy of the next several years, but that's perhaps a reasonable assumption. But what I find interesting is that 60 to 90% of all that development is going to be, quote, smart growth, which means 15 housing units per acre. Now, I love Kansas dearly. I've been here many times. I don't see 15 housing units per acre likely to be the future development pattern in Kansas. Certainly it's not going to be in Georgia, because that's almost communist there, okay? So this assumption is, yes, we can do it, but this means we all have to basically live on top of one another. I don't think that's going to happen either. But there are a lot of people who point to this saying, aha, this is the solution, not part of it. What about transit? I love transit. I use transit every day in Atlanta. I'm a strong advocate of transit. And yet, transit serves a very small portion of the current ridership. Yes, we may be able to increase that more, but even with a doubling and a tripling of investment in transit in this country, the likelihood of having any substantial transit ridership is not very high, certainly not enough to be able to make a dent in the greenhouse gas emission side of things. And what I find interesting is the European ministers of transport basically say, look, mode shift policies are getting people into transit, are possibly important, but they cannot really form the basis, the basic foundation of a policy to reduce greenhouse gas emissions in transportation. So transit important, but not likely to be the panacea. Well, let me just go to the next slide because this basically shows the same thing. There have been some very interesting studies that have shown that it can be a combination of strategies. And this is, I think, the key to what it is we need to do on the transportation side to reduce greenhouse gas emissions. This particular slide comes from Dan Sperling at UC Davis that for California said, look, there are different things that we can do. So for example, we can have travel demand, better manage our travel demand, not have as many people travel at the same time, perhaps people travel in higher occupancy vehicles, whatever the case is. And for light duty vehicles, that would reduce it from here to about here. For conventional vehicles, we could have different types of engine technologies that would be able to there. That would reduce it to here. Introduction of biofuels, introduction of electricity or electric vehicles, hydrogen vehicles. What they're basically doing is saying, here is the phasing that we need to put in place in order to reach this reduction where they're trying to get down to an 80% reduction from 1990 levels in California through a packaging, if you will, of different types of strategies. And I'm going to come back to that later as one of my conclusions. Well, I told you about growing cooler, which is the development side. The transportation people got upset and said, well, what's this nonsense about growing cooler? We need to move cooler. And so last year there was a major study called Moving Cooler, which is to, in essence, say, what can we do on transportation to reduce greenhouse gas emissions, all right? This is a major study funded by 10 or so different professional organizations. What they did was to say, what are the different types of strategies, transportation strategies, that one can look at, and they bundled them. They put them in packages, more or less, and came up with what are called 6 bundles. What's the low-cost one? What's the facility pricing one? How do we get better efficiency out of the system? What about land use, transit, non-motorized? So they bundled these packages together, and then also said, well, we can just implement them, which is to expand current practice. Well, we could also have more aggressive implementation, or we could have maximum deployment of this bundle. And here's an example on the bottom of what they meant. Expanded is, well, we're just going to toll interstate highways at a minimum of 2 cents per mile by 2020. That's the kind of expand practice. The maximum is we're going to toll all interstate highways at a minimum of a nickel per mile by 2010. Okay, so we're going to be much more aggressive, if you will, in terms of that particular strategy. Here is the maximum bundle. Okay, look at some of these strategies. 90% of the new land is compact. 1.6 trillion increase in transit investment, which if you know anything about transit, I love transit dearly, that's a lot of money. 120 metro areas now have congestion pricing, which means if you're in congested at the times during the day, you're going to get charged for it by 2015. Interstate highway tolls, 55 mile per hour national speed limit will clearly be enforced by 2015. I came from Kansas City last night going 85 miles an hour, and I was the slowest car on the road. $400 parking permit fee, 50% transit fare cut, reduce fares, encourage more people. The bottom line is this is what's considered to be the maximum, most aggressive bundle, okay? What do we achieve from it?